Okay, let's work our first example of tangent planes. This is the formula that we defined on our last lecture. So this is z minus z sub 0, which is the dependent variable or the response or output variable. And this new, because the plane is another function, this is equal to the partial derivative of the function with respect to x evaluated at these points times the differential of the point with respect to x plus the partial derivative with respect to y, and we are going to evaluate that in these points, which are the same as these points, times the differential but in the y-axis. And this will result in our tangent plane. Okay, uh, let's write our function here. Let's say that z is going to be equal to 2 times x squared plus y squared. And let's write here, find the tangent plane at the point 1, 1, 3. Okay, so this is an elliptic paraboloid. This function is an elliptic paraboloid. Um, if we have time, we are going to do this in a graphical software, so we can see it. And let's find the tangent plane at this point. Okay, so what's the first step? The first step is to calculate the partial derivatives of this function. So let's write here in this space, let's write here the partial derivative with respect to x of this xy function. And if you do the proper calculations here, you will end up with this is equal to 4x. And the partial derivative with respect to y of this function is going to be equal to 2y. So this is an easy one. Okay, partial derivative of this with respect to x, 4x, and 2y. So we have this function here. So let's evaluate first, because we need to evaluate the partial derivative in the points 1, 1, and we need to evaluate the partial derivative with respect to x in the points 1, 1. Where this 1, 1 is coming from? Well, this 1, 1 and 1, 1 are these two 1, 1. This 3 belongs to the z-axis, so we are not counting this because we are going to use that in this part. And now we are going to calculate this. So if we evaluate the function 4x, which is the partial derivative with respect to x in these points, we will end up with this is equal to 4. And in this case, this is equal to 2. Okay, now we have this part. We have the function evaluated in this. We have this part, and we have this part. Okay, and we are almost ready to calculate the tangent plane. Okay, so using this, with this expression, we can say that this is, let's say, tangent plane is going to be equal to, in this case, c minus 3, which is this 3, c minus 3 is equal to the partial derivative evaluated in the points of reference, and this is 4, which is this 4, times x minus 1 in this case. 1 because this is the point that we are going to be dealing with. And then plus the partial derivative with respect to y evaluated at the points x sub 0, y sub 0, in this case is 2. So this is equal to 2 times y minus 1. Okay, and doing here the calculations, we will end up with this is equal to z equals 4x minus 2y minus 3. Okay, and this is the equation for the tangent plane that passes on the top of this elliptic paraboloid intersecting the point 1, 1, 3 in this surface. Okay, now this is the analytic way to do it. Let's do a little bit of additional work here. Let's use here the GeoGebra. You need to type it just like this, geogebra.org /classic, because there are another type of GeoGebra that is not calculating any um, graphing. So please type it like this, geogebra.org /classic. And if you click here on view, you can click on view and select 3D graphics and get rid of this first graphics menu. And then click again here and you will have this. If you hold a click and you can turn with your mouse or your touchpad, you can see this 3D plane moving. If you want to be more comfortable, you can get rid of the plane. Right click, click plane, and you will have more clean view of this 3D plane. So here in the input, be sure that you have this activated, this algebra menu. You can have here in the input, and let's write that this is let's say h, and this is equal to, let's say the first function was 2 times x squared, and that was plus y squared, enter. So this is this part, which is the elliptic paraboloid. Now you have it here, you can see it. So this is the curve function of this. And let's type in the point P. Let's type the point P, and this is, let's say this is equal to open the parentheses. Let me see if I can write it correctly, because sometimes 1, 1. No, this is not correct. This is equal to 1, 1, 3. Let's see if this works. It's not working, also not working. Okay, So let's just open a parenthesis, 1, comma 1, comma 3. Okay, that's it. You need to open a parenthesis and then type 1, comma 1, comma 3, and you will have this point. In this case, here is shown as A, but we know that this is point P. Let's rename it. Let's see if I can do that. Okay, we can do that. So this is point P, and this is the elliptic paraboloid that we were working with in this expression. Z equals 2 times x squared plus y squared, and the point P is in the coordinates 1, comma 1, comma 3. So this is the point P. And now we already calculated the tangent plane. So this is equal to 4x minus 2y and minus 3. So let's write another expression here. Let's say that this is r, and this r is equal to, let's say, 4x. Let me do it again because I did it wrong. This is r equal to 4x plus 2 times y minus 3. Enter. Okay, so this is the elliptic paraboloid, which is the blue shape, is a curved surface, and you have this point A, point P, I'm sorry, point P at 1, comma 1, comma 3. And if you see, all the purple surface is a flat plane, and this plane is the one that you have calculated here, and you can see and confirm that in effect this plane is tangent to the surface of this elliptic paraboloid at point P. Okay, there's a lot of things that you can do with this application. Uh, Later on, we are going to perform more exercises here. Sometimes it is not very stable, but you can close and reopen again and practice with it. It has very intuitive input language, so you can use it to calculate and see, for example, vectors, cross product, dot product. You can use it to verify your results, because in the future you're not going to write everything on paper. At this time, you need to be able to use a certain type of software to perform this calculation. So this is a good aid to do that. I hope it helps. And this is how it's done in regarding the tangent planes.